these things and we're using them as switches and stuff, remember from our cluster to our emitter, we could just treat these things as switches. So if we wanted to analyze how our circuit was working, we just treated them as switches. If the switcher was turned off, the switch was open. If the switch was on, we had a voltage on our base, then the switch closed, and then our current started to flow. Well, that's kind of the same way we can look at the op amps too. When we're looking at the op amp, here's my output. The only difference is that here I have two choices. So, for example, if I have 1 volt on V1 and 0 volts on V2, we know that V1 is going to be more positive. It's on my non-inverting output, so my output is going to go to my positive 13.5 volts. So basically, since it's an open loop comparator, it's basically a switch. And so what's going to happen internally into the op amp, it's just going to take this output and it's going to tie it right to my positive 15 volts VCC. It's just going to go click and bring it right over to here. So then my current tap then, so here's my negative positive. So my current tap come out of here, come up into here, and then it's just going to, on this type of particular circuit, it's going to come up and it's going to come to a stop. There's nothing connected to it. So I don't have any current flow going through my negative side. But if I look at my other power supply, you can look at this current. Here's the current coming down. We know we don't have any current going this way because there's nothing hooked up to it. It's just a loose wire that's going into my op amp. So the only other option I have is either going this way or I can go through my ground. It's going to come down through my ground, up through my ground, go negative positive across my R1, into my op amp, and then up into my, because the switch is made and it's tied to my plus 15 volts VCC, and then back up into my source. So the only one power supply that I'm actually using is just this one. That's the only one that I actually have actually current flow. There is no current flow going to my negative side. Now if I go ahead and I switch that around, and I go right out of the ground and I put plus 1 volts on V2, this time I'm more positive on my inverting, so I know that my output's going to go to a negative 13.5 volts. My switch is going to switch and it's going to go down to my negative 15 volts VCC. Now this time, now my current is coming out of here, going up, it's going up into my op amp, out of my output, across my resistor, up to my ground, and then back into my source. So now this time I'm only using my negative side of my power supply, and you can see that the voltage across my resistor has changed polarity, so now this time it's going to be at a negative 13.5 volts. So when we're analyzing op amps, you can just treat them, especially when we're using an open loop comparator, just treat them as switches, just like we did when we were looking at a transistor. It's just a solid state switch. So either switching it to plus 15 or negative 15 volts. And that's kind of one of our benefits of having an op amp, because we can go ahead and we can swing it both ways. So for example, I'm going to do it on the transistor, and if I had plus 15 volts, if my transistor was turned off, I'm going to be measuring across my open and I would get a plus 15 volts. And if I turn the transistor on and the switch closes, then it's going to go to plus or minus 0 volts. That's the only choice I have. I only have either plus 15 or negative plus or minus 0. Those are the only two choices. Here I can have it either negative 13.5 or positive 13.5. And the benefit of that is because remember when we're doing our common emitter amplifier, remember we had to have our voltage dividers in there to bring up the AC signal. So for example, if I was going into a common emitter amplifier, and my input signal was going both plus voltage and negative voltage. If I didn't put it into my common emitter amplifier, if I just put it into a transistor, and I tried amplifying the signal, the only signal I could get would be to have it go up to my VCC, my plus 15 volts, and then down to plus or minus 0 volts. So my output signal then would look like, because it could only bias one way, I could not get a negative voltage because I don't have a negative source on there. And since the transistor only works one way, I'd only be able to get one type of a signal out there. Well, an op amp, since I have my dual voltage and goes plus or minus 15 volts, if I send that same signal into my op amp, then I could go ahead and it could go up to my plus 15 volts, negative 15, plus 15, negative 15. And so then it could go ahead and go up to my plus voltage and my negative voltage. And then depending on whatever my gain is, would be whatever my signal is. So that's another benefit of an op amp. I don't have to build up a whole bunch of voltage dividers or anything like that. And since I have dual power supplies in there, my output signal then can go positive, negative. I don't have to do anything. I don't have to bring my AC signal, my input signal. I don't have to elevate that up onto a DC offset. I don't have to do anything like that. I don't have to do that with my DC output either, or my offset of my output either. I don't have to have that on the output. It'll automatically just go ahead and swing positive and negative. But I remember on the common emitter, to get that AC signal, I had to have that whole thing elevated greater than the 0 volts for it to get the whole signal. Then we went through the coupling capacitor, and then that blocked out the DC and just allowed the AC, and then it converted it back into an AC signal. So some of the other benefits of having the op amp is they're a lot more stable, the gain is a lot more controllable. You don't have to do a lot of circuitry. We can hook an op amp and a couple of resistors, and we have ourselves an amplifier. And that's what we'll take a look at next year. We'll take a look at our non-inverting op amp with gain.